Hi there, this is Koiro, and this is my 7th episode on the Commodore 128. And even I do think that this series has gotten quite long enough, but we are not quite finished yet, and there are still a lot of things to learn about the 128, and we must consider that I've not even started on the normal wedge-shaped 128s yet. This has almost all been about the DCR. Of course, some of the theory is common for both models, but a lot of the things with room ships and power supplies and other stuff, it's unique for each model. And this time I actually discovers that we have to take a detour, but the main purpose of this board was to check out if Tommy's DCR board was completely restored, or if there was something not quite right on that yet. And we do have a suspicion about that, because we didn't get the ready prompt without hitting the control run stop. So I do think that there is something on the drive interface side of things that's not making the bus from the ISC bus ready, so it will get the prompt on the 128. So that's where we start on this video, but I will warn you, there will be some detours in this video, and we have more theory to cover. So just let's jump to it. Yeah, this is kind of where I left off this last time. I'm going to do one more thing with this. I'm having these German prompts here. I'm going to make the Norwegian ones, and Tommy can select which ones he chooses to use. And this has been standing now for almost 2 weeks. And I'm going to turn this on now and check if the test run as it did last time. Just to check the stability of this board a bit before I take apart my 128 DCR. I'm going to test that before I take it apart, and I'm going to check to see if everything is right, so I'm sure that I'm not destroying anything, and that I'm sure that this board actually is ready for a test in my DCR. So I just make so that this don't short out anything. Should be like so, and this I had to pull before the test starts and put it in afterwards. Everything should be ready to test now. The diagnostics is running, and I try to put this in, and we just have to wait and see. I'm going to complete this diagnostic running twice and see how it goes. As you can see, I have changed to the 785260 diagram again, so it's identifying the memory chips as they should. And hopefully the test harness also will be good, so that the only error I get is the 8580 SID chip. And I'm running this on 5 times the speed, so the test will be completed in no time, I think. Then we have run this 2 times, complete test, and the only error is the 8580 U5. So I have no intention to testing this anymore. It's on to dismantling my 128 DCR to make the proper test of this board and see if the floppy interface and the ISC bus is working as it should. And I think the conclusion we can draw this is that this board is now stable. I have tried to lift the corners, and I not been banging it about because this has to be handled carefully, but I can't find any other fault. So I will just lay this aside, and I will take my DCR and put it on the bench and dismount the main board. I do have to dismount the main board, but first I have to take out the power supply and I have to take out the drive. Because these connectors and stuff, they are not long enough so that I can put the board on top of something and have it work. That will be too risky, so I will do the other risk. I will take out my board and put this one in. As you can see, I'm using my trusty really old Galo driver to dismantle this. I got some cooling paste on this. I got it on my fingers. That's not good, but the thing I'm most afraid of in this is damaging the drive, so I will be very careful when handling this. But I do have to take it out to reach the bottommost screws on this main board. And as I said, I have been considering putting in this board and just trying to make these cables reach and stuff, but I won't do that. I just instead try to be as careful as I can and just take out the board and of course the power supply. Yeah, what probably bothers me the most is that I also have to take out these cobwebs and stuff and dust. This is authentic 80s and 90s dust in here. Pop out the lever. I'm not sure if I need to dismantle this plastic because this drive will probably slide out just from the back. So we have to see. Maybe I should put one screw back in. It's not quite the same power supply and adapter as it was on the Per Vidars, but it's fastened the same, at least here. That's the power. And you can see some more dirt and filth in here, but I will concentrate on taking out this drive. I do have just one more screw. These connectors only fit one way, so there is no real risk in taking them out, I think. And there you have the drive mechanism. There, put it aside like so. And then it's just these screws in the bottom. Yeah, and I also wonder, I do think I discovered that I needed to take out these as well. Yeah, I'm probably missing something here. I said that I probably didn't need to take off the plastic front, but actually the red and white wire, that is the drive LED, I probably has to take that one out. That is a screw through here. So I probably have to take it out to get it in place, but possibly I will get it out. Okay, so this is also clipped in place by something. I wonder if that is why Tommy had desoldered this instead, because there is a clip actually in the back here that has to be loosened for this to slip out, like so. I really don't need this to test. Of course the read write light is fitted on Tommy's machine. I did place a dummy there, like so, and all the screws are in place here. So I'm just going to lift this away. Yeah, some more nice authentic dust and some flies and other stuff. But I don't think the Arctic Retro board would mind at all. I think it would, for the board it will feel like coming home, so I just slip it back in here. And to keep things in place, I'm just going to pop this one in the middle, so that I have something to lean the power supply on. And of course I do have to take the delicate drive mechanism and slide it in so I can get the connectors plugged back in. Okay, that is not totally the same. My connector is this, it's upright, but this is sideways. Okay. Let's just hope that's the only difference. And the power supply, I need to insulate it so it's not shorting out anything underneath here. I'm only going to let it rest on top of this here, like so. And that is really what I need to give this a test. I do need to be able to hook up the video display. I do need to hook up this power and of course the video, and the dummy for the test harness I of course won't bother with. I know I said that I should do a test of the drive before I dismantle this. I totally forgot. I of course should have done that, because now we don't know if this drive still works, but we have to assume it does. Let's see what we got here. We got the video pluggy thingy here. We got a power connector. And I need to connect the keyboard. This is all plastic, so I can keep this here. Of course I can't, because this is doing the loop here. Yeah, I will just do it like that. You don't have to see if I type it what I type on the keyboard. So I just have to optimize my space here. I don't have any more space on this workbench, unfortunately. First we're going to check that thing starts. And I'm going to, I have this main plug switch that I used before. I have to connect first, and then I can switch on here. And no signal. This was a bit odd. I don't have the power indicator LED on, so I first check the connection here, and then I check the connection in the back, and I don't have any power in, it seems. This was a bit annoying, to put it at least. This was not where I expected the troubles to be. And I actually discovered this. This is a blown fuse, and this is the intake fuse. It's a 315 milliamp fuse, 220 volt. Or 250 is the rate. I have to replace that one, and we try again. What has made the fuse blow? I'm not sure. And this is the new replacement fuse, and I don't know if you can see this on camera, but it actually is crooked, so I'm not sure what's up with that. But I've disconnected power, and I'm just going to replace it. Like so. And I'm just going to connect this again to see if it blows again. And that was the power, main power on, and it blows straight away. So we suddenly got a power supply issue here. I am going to disconnect this to see if it's the main board or if it's the power supply. So I'm just going to try with yet another fuse. You see, this is what happens when you are dealing with old equipment, and why I was afraid to take an and do the touches with my board here. There is really no way to know what happens when you are dealing with this stuff, and of course it could be something, so I just connect this. And we do also have the uncertainty with this point, but this is just the signals for the stop here and other things, so I don't think this will affect anything at all. And of course I have this put on with this paper down here, but this should be a perfectly good insulation. So I don't know, but I'm going to use another fuse. Same kind, also looks a bit crooked. Turn it off. New fuse off. Insert power, and now I disconnected this, so I do know that it's an internal fault on this power supply if something blows. And it blew straight away. Yeah, but we are going to continue this test anyway. I'm just going to reverse my test rig here, because I do have this slightly prepared for this, but I'm going to take this one away, of course. More things to repair, yay! And I'm going to stick this in like so, because as you know I already have this 12 volt contraption here that should also drive this mechanism just fine. So yeah, just plug. And you can see here on the screen, this drive never reaches ready. So we do have the same kind of faults here that we actually had on the Per Vida drive. What is really happening here, I am not really sure. But on Per Vida's it was actually two faults. It was this one, and it was the EEPROM for the drive that was not working. So maybe we just start there, make a new EEPROM for this drive ROM and take it from there. But yeah, somewhat disappointing that this power supply was gone and that we couldn't get this to work straight away, but I'm just going to fix this and I'm going to turn this off, because this drive is now spinning and never being ready, so I won't leave that spinning for now. I'm just turning this off. Yeah, I have now tried to change the ROM on the floppy drive, and it still was the same. That means that these buffer chips down here, the 7406 and the 7407 chips, needs to be desoldered or some legs cut to couple this part of the board, that is the 1571 part of the board. It needs to be disconnected so that we can do the fault finding on this. But I've spoken to Tommy, and he might think that I've used long enough time on this board, so he said just ship it back and I can continue from here. And of course he can. He has done a lot of work on similar things, and he also have a working 1571 that he can use to test on the system once he has disconnected the data lines on the IEC bus here. Then he can connect his device as device 8 and try everything as it should be on this one without having the drive connected. So he has the proper equipment. I don't own a 1571. I do own some 1541s, a lot of them, and some 1451-2 drives. And I also have this IEC SD to IEC devices that I can connect here, but I don't have them here actually. There was someone that has borrowed mine working one of these. So Tommy is getting this back. We are positively sure that the board is stable enough, and we have experienced that this power supply thing is working, and we also seen that the board itself, no, we have moved it. We have actually tried to test it with this drive and so on. So it's better that he takes over. I'll take it out the other way. I think that is safer. He will take over this and make sure that this got the proper treatment. And there is one more thing that I want to show you about this board, and that is the repair that I did underneath here. As you might remember, it was this EEPROM down here and the connection to the A12 line on this one that was bad, and I did solder in this long lead for this. But afterwards I did some work and I was checking out, yeah, whatever could be the fault on this. And there actually are some vias down here that could be the fault, but I discovered that it actually was the solder just on the pin here. So I just put some solder not on this ship here, but actually on the ship out here, the 157 ship. There was a break in the line. So I just did this by soldering on and taking away some solder mask and making this solder wider. I fixed this without having to apply this long lead. You actually can see the rest of the repair here for this. So that is the status of this board, and I also have is leaving in the 4066s that I've put into this board. It's two new Philips 4066s that I'm leaving in this board, and also I have these Norwegian ships for character rooms. Tommy had some versions of those too, but as it's these rooms that I've done the final test with, I just leave them in. But Tommy's original German, both character room and kernel room, is actually working, and yeah, and probably this too. This is the room for the CD-ROM drive, CD-ROM, the floppy drive, and I'm just leaving that in too because I know, as it is now, it's working, and the original room is of course going back to Tommy. So that's it. We are leaving Tommy's board for now, but I'm going to put my original 128 DCR back, and I'm going to test it with the other power supply, and I'm going to do some fault finding next on the power supply after I connected this together. Yes, and as some of those who have a nose for that kind of thing, you will see that I've brushed away some of the dust in here. I'm not doing a total cleanup, but there are some specks of rust down here, just some small specks. But and same over here. But since I was disturbing the 40-year-old grime anyway, I was just blowing some dust off this board and this case. I'm not going to clean it or do something else, but I'm taking a light brushing of this with an anti-static brush. And I'm just going to screw this back in, and I'm going to fasten the power supply, and I'm going to perform a test of this with this power supply, like here, and afterwards I'm going to focus on looking into the other power supply if there is not any fault with my board. And I do have a bad feeling. I don't like to take things that is fully working and disassemble it and put it back together. There always is the risk. But as of now, I'm just going to assemble this back together. And as we do remember, it was lots and lots of screws for this. And this in the center as a guide, and we can just start with one in each corner to make sure that we have the proper alignment. And as I said before, these screws are fairly long, but they are probably made as long as this, so that one side should fit all, because on the joystick connectors and the RGB connector we actually do have this to go through the plug as well. But by today's standard, they would never have produced anything like this with this many screws and this time of assembly. So they would have used fewer screws, maybe some plastic fastenings, and of course they would have used shorter screws to reduce the time used to mount this on the factory floor. When it comes to color, you know that Arctic Retro's board, it was totally green, this dark green board, and well, that kind of looks nice. I do think that this kind of board with this combination of brown actually looks nicer, and it's also easier to follow where the traces go on the board actually. Yeah, putting things back together is, like they say in Hitchhiker's Guide to the Galaxy, it's the opposite of the Big Bang, it's the gib-gnab. So I always say it's a gib-gnab when I'm putting things back together. Like so, and this board here, through that hole. These long leads from the Commodore side is actually two leads that is toasted in the same plastic. So it looks like one lead, but it's the diffused plastic that actually has this. And of course we do have to fasten the drive mechanism. That one went well. Yes, there, that one is fastened back in place. And you're not able to see this good on camera, of course, but this one goes like so, and this one will have to clip in like so. And one plastic screw. These are threaded inserts into the plastic, so be careful. Yeah, and this one should of course go to the power supply, and I'm going to do a quick test here with just this power supply. It's not plugged in at the moment. You can see the LEDs are dark, and this also has the 12 volt power supply connected. I'm going to connect the video, and I'm going to try to plug this in. Now it's without the keyboard. Yeah, and you can see it came right through. So I will connect the keyboard and try to load up Gauntlet so that we know that this is still working. If I can find my Gauntlet floppy disk, I might have forgotten that in Per Vidar's computer. I have to check. Now we do have our Gauntlet disk. So I'm going to carefully put the drive handle back in place, if I haven't lost it. Like so, and the keyboard. Are you sure? Yes. This -8 is the device number, and when you write the -1 is to actually load it into the same memory address as it was. And in machine language that's obligatory, otherwise it will load everything from the start of BASIC. But in this kind, where it is a file that you have to run, it's not auto starting, I do think it's good enough. Yeah, as I'm not using my capturing device, I'm only filming off the screen, I won't get any audio of this. So we can, be satisfied with that Gauntlet is loading, the drive is working, everything else seems to be working, and I can even assure you, even though you can't hear it, that the Gauntlet music is playing as it should. So except from the power supply, my 128 DCR are still 100% okay. So we are going to dig into the power supply issue now and see how far we get in this episode. Yeah, we do have to cover some theory, and I go to show you some background on this. I already commented this, but I don't remember if it made it into a video. This one here, I'm actually going to draw for you with orange color, I think. This one here is the power supply that was in Per Vidar's 128 DCR, and this is the one I did have in my other DCR, so it's the same. But in some sources on the internet, it stated that this is the newer one. But this has a date of 1987, and this has a date of 1988. And this is the power supply that is contained in my version of the DCR. And if we are thinking from this point of time, I do think that this construction here actually was more cost effective, because you only have one transformer, and this is output maybe noise rejection or something, but I don't think this takes an integral part of the power supply function. And we are going to look at the schematics afterwards. This is the fuse that kept blowing. And what's causing that? We will look at the theory first, and then we start out with what we know. But this one here actually has 3 transformers on board. It has more capacitors. It has more aluminium heat sinks. It delivers more power, at least I do think it does. It is about component choice and stuff, but this is what's stated. It stated that it delivers 5 volt, 4.5 amps, 12 volt, 1.4 amps, and 9 volt, it's 0.5 amps. And as we see here, this fuse here that is on the 9 volt line, it's only 350 milliamps. So already here we can see that this delivers less 9 volt AC than this one does. And also in the 1987 version of the service manual, that is the one that we have used throughout our series, it's clearly a picture of something that looks more like this power supply than it does our power supply. This might be an American, European, kind of thing, and this is also a less detailed sketch than what we have here. And we also have the components list and the schematics here for this power supply. And you can see here the 12 volt is a series regulator, and this also regulates through this thyristor here, and it switches to this drossel up here to make the 5 volt switch mode power supply, and you do have the feedback circuits here with an optocoupler. So this is a pretty straightforward power supply for both the 5 volt and the 12 volt, and the 9 volt is unregulated, and it's an own transformer T1 that is doing this. So straightforward, but lots of components, and this is not the most efficient way to make a power supply, but the power supply itself is quite good, and they use a Darlington coupled transistor over here to actually make this series regulator able to provide 1.4 amps with a heatsink that is not too large. And this is our power supply, and firstly, this is what looks like a PCB. It's almost as solid as cardboard. This is the worst PCB I ever seen. It's like cardboard, really. And the parts of this power supply is that you have a separate winding that has 1 point here and 1 point here for the 9 volt AC line. And as we stated before, this is a 350 milliamp fuse, a slow blowing fuse. So this only is able to provide 300 milliamps of 9 volt AC, but as long as this only goes to the user port and regulating the cassette motor, that's quite okay, I think. The 12 volt is done by a 7812 integrated regulator, and this regulator with this really small heatsink is not able to provide more than 1 amp. In short period, maybe 1.2 amps, but in Commodore's world, they have always rated the need for cooling on serious regulators. And the rest of this that is marked with red here is part of the switch mode regulator for the 5 volt. But how much power this is able to provide, I really don't know. But as the second one was able to provide 4.5 amps, this is probably able to deliver almost the same. But remember one thing, I have been powering the 128 DCR now with my regular Commodore 128 power supply, and that is only able to provide about 2.5 amps 5 volts. So that is clearly enough to drive this computer. So I will guess, and this is just an uneducated guess or a partly educated guess, that this is able to provide about 3.5 amps with 5 volt. And that should be sufficient to run this computer if you don't provide it with the most aggressive cartridges. And also each of the power supplies have a different back and metal work here. And this is by far the cheapest one with the fastings for the power switch, and the power connector is just barely hanging in there. And in the schematics for this, they're using an integrated circuit, the 3624BN or 3524BN is actually what is on this one. And you can clearly see here that this is based around a switching transistor and some other circuits. And this, IC from ST is used in a lot of applications. And you can see here that this is really much less complicated and has less components than the other design. And here you can see the real simplicity of using a series regulator on this and the fuse and inline fuse for the AC. So this is clearly a cost-reduced design, so I do think that this is the later model, whatever else is stated on the internet. And I got these schematics and stuff from Simmers. They really have the best collection of schematics and stuff on the internet. And the future are already here. This is a power supply that Arctic Retro, Tommy, is going to use in his 128 DCR when he got the motherboard back. And this is based on a design, by Roy Carlson, I think. And this uses a separate 9 volt AC transformer, and it has a switch mode power supply module to provide the 5 volt and 12 volt as a standard unit that is just mounted in here. And this is of course the best solution and what we should do down here, because some of the 7812s, if they fail, they will fail shorted, and I can overrun the 12 volt rail. Otherwise, of course, modern power supplies are more efficient than what they was able to do back in the 80s. You must notice here that this design here is not really street legal in Norway, because it really demands that the first thing you are accessing when you are leaving the 220 volt or 230 volt rail is a fuse. And this fuse should be rated so that the component that stands in front of it, if that is shorted on the output, the fuse should blow. So this fuse here should maximum be the short circuit power of one of the rails here. But that's just a mentioning. But if you are doing things yourself, this is some of the things you do have to consider. That is really something you should consider if you are doing things yourself. And this, if you are going to keep it yourself, it doesn't matter that much, because then you're responsible for your own failures. But if you are going to sell it or give it away or doing repairs for others, then you really should keep that in mind. But there are more power supplies for the 128 DCR, and this is the American one. And it's quite similar to the European ones. It does have series regulator on the 12 volt, and it has a switch mode on the 5 volt, and just pass-through transformer thingy on the 9 volt AC. But it is more or less complicated than this one, because it has a single winding transformer in front. But of course 110 volt, it's a bit more simplified. And I'm lying when I say that you just have a single transformer, because you have a second transformer that takes down this voltage here, and regulate the 9 volt. But this is a beauty of a schematic, because you have the measuring points. You have the measuring points here, and they give a picture of what you should see on each test point. And I do like that a lot. This is what really makes a schematic in my view, because this is so super helpful that it even will give a very good learning opportunity on working power supply, what you should look for and how you should measure. And if your measurement does not look like the real thing, but the thing is still working, then you can adjust your knowledge about measurements. So this is something I really like. This is the fundamentals in keeping knowledge alive on analog electronics. But what are we going to do with our power supply? And what can I say about that? Yes, this is the fuse that keeps blowing, and that means that we have a short after this fuse. It can be this capacitor, that is a noise thingy. It can be this capacitor, because they are both shorted to ground. So on the the primary side of the transformer, these can be bad. On the other side of the transformer, if this is shorted, they could of course give a fault that will have severe damage stuff, but this most likely burns that there is a break. Would that affect something? I'm not so sure. But if these are okay, then this is the next culprit. This is not connected to any load, so I don't think if this is broken it will blow the fuse, but this shorted will blow the fuse. The 9 volt circuit is not connected to anything and has an inline fuse. That won't affect anything. So if we have not been able to solder something on the end here, this won't affect anything. And of course, when we dig further in here, this could be the culprit. It's a huge capacitor shorted to ground. And otherwise, if this one is broken, it won't take the fuse with it. So it's this regulator IC, it's these capacitors, maybe these diodes, and maybe this cap on the output is broken. That can make this fuse blow. But otherwise, I don't think we will see this catastrophic burning of the fuse if some of the other components are bad. And you have to distinguish between that's in series with the signal and can break and can short if they make a difference. And you also have to take into consideration if it's more likely that something is shorted or that it's just blown so that it make a break in the circuit. And breaks in the circuit don't make a short. So I'm going to measure out these components. I do think that these are fine. This is plastic and polymer caps. I do think they are fine. I will check this first, and this one second, and this one third first. So that's what I'm going to do. Otherwise, of course, I can go the Tommy route and just replace this with another power supply and just leave the rest in here to provide the 9 volt AC. And that is, of course, if the transformer itself is not broken. But I almost can guarantee you that it's not. A transformer that is so little used and has so little load, it won't break. And it won't break in a way that makes it a short, because it means that it has to get really hot or has to sustain some mechanical damage so that the threads in the drossels in the transformer is making a short, and that's not the case here. So I will dig into this and see what I can find out. Yeah, and all this talking, and I forgot to specify that a series regulator will never be above 50% in efficiency, so it will always generate some heat, even though it's little used and only in the drive not electronics but mechanics. It will dissipate some heat. So the 5 volt is switch mode, but the 12 volt should have been too. So in a modern solution, of course, you go for switch mode in the 12 volt too. Yeah, and I was back to looking into the schematic again, and the first thing I found was that there is no 3 4700 microfarad capacitors on this board. So the one that is marked C10 is actually a 330 microfarad capacitor, and that is more in line what should be at 7812. Yeah, and I'm not sure what happened, but I measured the input, and the input is just fine. I'm measuring at least 25 ohms, so the input is okay. And if I measure here on the output, I measure about 7 ohms, and that is not a blank short either, so the input and in front of the diodes and stuff, that's okay. 0.4 ohms and 0.5 ohms over diodes is really okay when they are standing like this with a winding straight across them. And 0.2 ohms over this capacitor, that's not good. I do think we have our first culprit, but of course there is one more capacitor too that stands in parallel. And I'm measuring back now over the diodes to see if I measured something wrong or there was some additional ohms in the measure leads, but it was not. So I do think here we got our first culprit, and this 330 microfarad capacitor could also be bad. It's standing on the 12 volt winding and it's on the output, so it's straight in parallel with this 4700. Yeah, so to be sure, I'm at least going to desolder this 4700 microfarad that stands on the input, but in the same time, I think I just desolder both the 330 and the other 4700 caps and see how they measure. And on this board, with this nice clean layout, just one layer board and stuff, I'm not going to bother with the desoldering gun. I'm going to use my really good desoldering wick with built-in flux, and this is going to be easy peasy to desolder. Yeah, but before I desolder, I will just go and just mark off all the standings of the caps on the board so I know what's minus and what is plus. I will be able to figure it out anyway by looking at this really simple PCB layout, but better safe than sorry, and I am known to make mistakes from time to time. Yeah, the input 220 30 volt lines from the plug and from the switch is a bit short, but I am able to twist them so that I can lay this flat on the surface. And of course, with this heavy transformer, this board is lying nice and sturdy when I do the desoldering. And the pads, they are quite huge, so there is a lot of solder, but it's an easy match for this flux-ridden solder wick. And actually, when I have heated this and taken away the solder, the capacitor just falls to the back of the board. It just falls out of the holes. Yeah, and then it's the other capacitor, the other 4700 microfarads, and this one is a 16 volt version. And it says about the bill of materials here when they bother to put in two different 4700 caps, because the price difference between 25 volt and 16 volt in these volumes will be very small. But they did it anyway, so every penny counts. Yeah, I'm also taking out the 330 microfarad capacitor, and I can guarantee you that the fault in this circuit is among these two caps that is on the primary side of this. But of course it's good to know if the 4700 microfarad capacitor on the output also is good. But as I said, this extremely quick blowing fuse, I do think that we are looking for a fault on the not the primary side of the transformer, but secondary side of the transformer, and before you start power control and power and voltage regulation. Yeah, and I go in and do some additional markings about the polarity of the caps. As I said, it's better to be safe than sorry, and yeah, these kind of mistakes happened. And here we are looking for a short, so I'm just using the ohm meter. Yeah, in this first one, the black 16 volt that's on the output, it measures like a capacitor should, it's taking charge, but I don't have my peak tech meter home as of now. And this golden one, you can see the fault at once. It's measuring at about 2 ohms, and that is a dead short for a capacitor. It by no means should measure this. So this one is a gunner. And this one, it also measures as a capacitor should. I have no means about the values and stuff, but as this too has been standing close to a heatsink, I'm going to replace this anyway. But I don't think that was our fault, or part of the fault. And as for comparison, you do have this that has changed carrier and now has taken a full-time job as a resistor on its old days. And is there anything special with this capacitor? No, it's not. It's just an ordinary capacitor. If I have had it, I will have changed this with a 105-degree part. Otherwise, almost bog standard. This is standing on the secondary winding of a transformer with two-phase rectifying. So this is just a 100 Hz normal smoothing capacitor. As a replacement for this broken one, this was 25 volt 4700, and I do have this one that is 3300, and I do have these that are 2050 volt. And I actually do think that I'm going to replace this. 4700 or 4000. I can of course replace it with one of this and this one. Then it will be 5300, and that is within the specs. But this is just 25 volt, and I do think it's a safer bet to use these two. They will be a bit smaller, but I do think it will be okay. And this capacitor here that stands on the output is the one that really will get the short pulses anyway. And I have this capacitor here. I do think this is okay, but I'm going to replace it with one anyway, because this has been standing right beneath beside the heatsink for the 12 volt regulator. So we have to see how we make these fit. I do the simple one first. These actually have the same size on the holes. That's the easy one, and then it is this one here, and it is possible to put in bigger holes here, because I can place it here just as a replacement, like so, the first one, like so, and then I actually can fit a second one over here if I just drill some holes. So am I going to do that? Yeah, yes I would. So I will go and find something to drill some holes with. And of course I could have brought out the Dremel, I could have bought out a mini drill, and I could have put this on the big drill that I have down in my tool shop, but I'm going for my trusty old DeWalt drill. I've just recently bought new batteries for this, so it would be a shame not to use it. And this makes short process of drilling the holes, and I'm drilling this with a 1.5 millimeter drill bit. It's a bit bigger than we really need, but it was the one that I could find just as of now, and this is a brand new drill bit. And I think we can agree on that this is not very good filming. I should have brought the camera in from the side, but it's only two 1.5mm holes, so what can I do? What I done now, I've drilled two new holes, and I'm just going to scrape away some copper here, so I do have something to solder against. Yeah, the solder mask on this was not very difficult to get off. Yeah, and I just try to make space for both of them. The holes is drilled a bit tight, but this is where it was safest to drill on these lines, and I can twist the legs anyway after I have soldered them in. Just of now, I'm just leaving them a bit from the print and placing them and doing the solder. Yeah, I just solder them there and see how this goes. I might have to do some adjustment. Yeah, like so. And how does that look? Yeah, it does look okay. Maybe a bit close to this cooling pad, but then again, the old one was that too, and it lasted for many years. So I'm just going to cut this now, and we actually are going to do a test. Yeah, just double check on the polarity. This one has the minus and the plus this way. And I did put up a bit longer lead so that I can bend it a bit away from this cooling fin. And this has the minus this way. And this has the minus that way. And this is the minus and that is the plus. Yes, because this is the center. So, will this work? At least we have uncovered one major fault. If there are more, yeah, there might be more, but I'm going to just fasten this a bit. And here I hope there is one of you viewers, or at least I hope I have one viewer that is that is watching this and that is now screaming at the camera, "You moron, you have to place the last output capacitor because I forgot to solder in the 4700 output capacitor." And I managed to screw it all back together. I even managed to plug it in, and that's so far I got before I realized my mistake and had to take it all back. Yeah, dismantling and taking the PCB out of the metal backplate. So again, we are experiencing a GIB GNAB, as in the Hitchhiker's Guide to the Galaxy, as the opposite of the Big Bang. But I do think that the rest after this is just a walk in the park. When we get this one together, it's just to measure out the voltages and see if we are within spec. And yeah, I think that should be easy peasy. Yeah, I did notice earlier that this connector is not the best in the world, but I do manage to get the cable in there, but it's not a very good fit. Then it should be on again. And see if we now got power. "5V, 11.86. 5 point, that's close enough. And alternate current, AC voltage, 10.58, yes. Then this should be good to go back in. I have to put in the last two screws, of course, and tighten the others. This one is broken, this one is new, it's going back in the box again. My DCR, and the power supply. And here it is 5 screws that needs to be placed. This is 3mm machined screws, every one of them, so they should not be really difficult. But what is with this metal thingy here, it's not totally accurate, so you do have to bend and fiddle a bit to make the different pieces fit. Yeah, I'm not going to put them all the way in until I have every one of them in place, because I did struggle a lot with this on Per Vidar's. And here I actually struggled a bit myself. I had this screw that was taking a walkabout, so I will have to dig into that later. But this is at least enough that I can say this is properly fastened to do a test. I'm not going to do a full test. Yeah, I have the light on, and I'm just going to connect. Yeah, the power supply is okay, and then I connect this one. Yeah, the reason I did this strange way of coupling things together is that I wanted to make sure that the earth on the chassis and the monitor was not making interference and making different ground planes. The drive is turning and the ready sign is switching on. So this probably is as it should be. So that's it. We've fixed the power supply, and I can give some comments about what I did. This cap for the 12 volt is a 470 cap. On the schematics it's actually stated that this should be on the input here, that this should be 4000. It's not that cap. This cap and this cap is about the same, so this is an error in the schematic, because this one and this one is in parallel, and you don't do 9000 microfarad on the input of a switch mode and a serial regulator. And this one here is 22 microfarad and is the output of this. So this one here, it should be 220, 300, 400 microfarad, and this one is adding up, so I do have about 150, 140 more microfarads than I had, and I replaced this 4700 with two 2000 high quality capacitors. So I do have about 4100 something there instead of 4700. But that will be okay. You know that back in the days, these caps, they was about 20% accuracy and something about 30%. So this is well within specification, I would think. So I'm going to put the lid back on this for the moment, and I'm going to park this. I did use this now to just verify the Tommy board, and now we actually got some useful repairs out of this when we redid the power supply. Yes, as you can see, we are not doing a strict clean desk policy at the Koiro mansion, or rather should I say the Koiro dungeon. This episode has lasted for more than 1 hour, and I won't take much of your time, but just a quick recap. First of this episode was to establish that the Arctic Retro board actually was working, and it was not. The board itself was working, but we do have some issues with the internal CD-ROM driver board that is integrated into the main board. And after a quick discussion with Tommy, he wanted to look into that for himself, and that is quite okay with me. I promised to help him to get life into this board, and I have. So that is mission accomplished. And we did run into a fault with my floppy, with my power supply when we was testing this. And also I was afraid that my my floppy drive was broken, so I did put it all back together, and now my DCR is fully working, power supply, the floppy drive, and everything. So I'm going to put the lid back on that, and the next thing I will be doing when it comes to Commodore 128 is actually my scrap board. And it's this board here. I have shown it sometimes before on this series, and you can actually see here this is missing a lot of components. One of the reset switches is gone, some of the power things are gone. There has been some desoldering, and yeah, a lot going on with this board. And there are some unoriginal chips. There are some bodge wires both on the top and on the bottom. So this 128 has seen some action, and that will be a challenge that I can take on in a future episode about the 128. But as for now, episode 7 is the last one in this series, and then we are going to revisit the 128 again. And it has been a struggle, and it has been fun, and it has been really interesting, because the 128 is a computer I did not much dig into back in the days. I did use one. I did have a friend that had one. We did a lot of programming on 128. The keyboard was beautiful, and it was really nice to be acquainted again with this computer. And I don't think I will be keeping my 128 DCR just so far stacked down as it has been, so I might take it out a little bit more often than every 10th or 20th years or something. So I hope you enjoy the content. I hope you will follow me in my next video. What the topic will be, you have to see. I have 3 or 4 topics that I have started on but not been able to complete. But my priority task will be cleaning up my desk. See you in the next one.